estimate the area under the graph of f of x equals cosine of x from x equals 0 to x equals pi halves using 4 approximating rectangles, first using right endpoints and then using left endpoints. Okay, let's just draw a very quick sketch of what this graph looks like. Cosine of 0 is 1, and we know that cosine of pi halves is 0. And we know that this part of the curve looks something like that, more or less. So we have this region, which we can call S. And this is a region that is above the x-axis and below the curve. And it's bounded on the left by x equals 0 and the right x equals pi halves. So that's what we're dealing with. So let's think about what this is going to look like if we're cutting this into 4 rectangles. First, let's just cut it into 4 strips. We know that we're going to have to make kind of 3 cuts to turn it into 4 strips. And if this is pi halves, half of that is going to be pi fourths. So that'll be at pi fourths. This is going to be at pi eighths. And this will be 3 pi over 8. It's important to figure out what all of these values are, because those are what you're going to be plugging in for x to figure out the height of your rectangles. Now, we're asked at first to use right endpoints and then left endpoints. So let's start with our R4. And if we're using right endpoints, this one right here, the right endpoint is actually at a height of 0. So that's not going to have any height at all, which is interesting. So we're only really going to have 3 of them. But let's write these out one at a time. If we start with this as a right-handed rectangle, the base of all of these is going to be pi eighths. And then the height is going to be given by cosine of x. So in this case, it'll be cosine of pi eighths for that first rectangle. And then plus pi eighth times cosine of the next right endpoint, which is pi fourths. And then plus pi eighths times cosine of the next right endpoint, which is going to be 3 pi over 8. And we said the last height was going to be 0, but let's actually write this out as cosine of pi halves, just so we have everything written down nicely. And one thing I want to point out, when we're dealing with these rectangles, they're always going to have the same width. And so it's always going to be that same number out front. So we could, if we wanted to make it a little bit easier, just put that out front and then put all of the heights on the inside. And those are going to be the function values, which is going to be cosine of all of those right endpoints. So we're going to have cosine of pi eighths plus cosine of pi fourths plus cosine of 3 pi over 8 plus cosine of pi halves. And I am just going to put all of that into a calculator and get our approximation for the right-handed rectangles, and that's going to be about 0.790766. All right. And then we can do the same thing for left-handed rectangles. I didn't actually draw in the right-handed ones, but we can draw in the left-handed ones. If we drew both of them on the same one, that would just complicate the drawing, I think. So here are our left-handed rectangles, and you'll notice that the difference here is that the heights of these rectangles come from the left end points of each of these intervals. So it's going to be very similar. All of those widths are still going to be pi over 8, but then when we're evaluating the heights, we need the function value at the left end points. So that's going to be cosine of 0 plus cosine of pi eighths plus cosine of pi fourths plus cosine of 3 pi over 8. right? This is the width of each of those rectangles. And then these are the heights, because we're evaluating cosine at 0, pi eighths, pi fourths, and 3 pi over eighth. Those are the left end points of each of those little intervals. And just putting that into a calculator, that gives us about 1.1834665. So those are our approximations using 4 rectangles, 4 strips. Now, if we wanted a better approximation, we could use 10 rectangles, 100 rectangles, 1,000 rectangles, and get closer and closer and closer to the limit. We're not going to do that in this problem. That would take a lot more time and calculations. And the goal here is to just get a little bit of practice setting up what these are going to look like. But I will tell you that when we look at the limit of the areas of these rectangles, when we take more and more of them, we end up getting 1, which is conveniently about halfway between these two, so probably not a huge surprise. And in the end, this area is actually equal to 1, but again, we don't want to have to go through all those calculations in every single problem right now. We just want to get practice setting these up. So there you have it.